We're going to talk about band-limited signals. And an example of a signal would be e to the j omega. So that's a noun. That's our input signal. That might be our output signal. And we'll graph it versus omega. And here's its unique, draw it out a little bit further. Here's its unique point between 0 and pi. And if we have, I can't, unfortunately, this is complex. I'm going to draw its magnitude, so I can draw it in just a two-dimensional screen. And it might have a lot of low frequency content. It won't be perfectly low, but it might have a lot of low frequency content. And you know that although we typically don't have to draw it, there's mirror images over here and it goes on to infinity. But this is a low frequency signal, not a low pass filter. A low pass filter is what this would be if it was a H, if it was a system, if it was a verb. But as a signal, it's just a digital signal that's got a lot of low frequencies in it. And if it was a high frequency signal, it might look like this. And that's a little bit confusing, right? Because that means a band pass signal might look something like this. And so it's easy if you quickly look at an x of j omega and you see something that looks like the orange sign to say, hey, that looks like a band pass. But because it's centered over pi, it's in fact a high frequency signal.